So now we're moving on to what I've called extension of the carbon calculator, because there are quite a few questions coming in thinking about can we use this on different sites in different ways, and this is a second question that Tom put in. Is there scope for offering an option of calculating the short and long-term effects of forestry on deep peat and carbon balance to compare, for example, with felling and restoration back to an active log as part of the mitigation program? Would you like to say anything else, Tom?
The question's offered because I've used the calculator for a very large wind farm proposal in Wales, a site called Carneth Wen, where there's a very large habitat management plan going in, where about 14 square kilometres of forestry will be taken out and restored back. Much of it, we hope, to blanket bog. The actual rides still have excellent blanket bog within them. Just walking the site, I've even found 2 new raised bogs within the site. Wales only has 20, I found 2 new ones. So there's a lot of potential here if we can get the trees off. And I think this as mitigation is going to be a very strong element of some of the bigger proposals which might go in the next decade for onshore.
So you say calculation of carbon savings from forestry for grounds that involve tree felling for a wind farm. The current forestry component of the calculation takes no account of situations in which forestry to be cleared for wind farm is established on deep peat.
What effect has the forestry had on the carbon store in the peat? At the moment, according to the calculator, if you're removing the trees, the carbon sequestered in there is knocked off your carbon savings.
The carbon in the trees is not off your carbon savings, yes. But if you had an area of forested land which had been drained with forestry, and then you locked up the drains, then that restoration is accounted for in the restoration sheet. Improvement, I should say. Sorry. So, is that what you're getting at? So, sorry, I keep changing your
Do you say there should also have been a negative component because the fact that the forestry has an effect on the peat is not being taken into consideration? But what's happening now is the fact that there's going to be a positive impact on the peat by deforesting. That will be taken into account,
yeah.
But not the carbon that could have additionally been sequestered by having the forestry there.
So, improvement of felled plantation land. So you put in the area that's felled, the water table depth before the improvement. So in this case it's deep because it was drained. The water table depth after the improvement. So you've blocked up the drains and the water table depth has come up. And the time required to get there. And that will then mean that you have carbon gains or reduced losses due to that effect. Now, any losses that occurred, I think what you're saying is, I'm not sure what you're saying is not accounted for.
On the impact side as well, if the forestry's been on the bog, hasn't there been some sort of carbon loss from the bog under the forestry due to not enough rain getting to it, the roots pulling up the drainage?
But that's not attributable to the wind farm.
It's
So
due to
exactly.
forestry.
Previous forestry.
Exactly, but the model doesn't. Does the model assume that that there is forestry when you're actually calculating the emissions rates for the soils? Has the effect that forestry's had on those soils been taken into account?
Yeah, because you've got the water table depth at the start. So where you have your forestry, your water table depth has gone right down due to drainage, due to increased evapotranspiration. So you've got your water table depth is down and you've got carbon coming off as a result of that. Now if during that time you'd just left the drains in place, you hadn't felled the forestry, then you'd have a certain amount of emissions that are going on during the lifetime of the wind farm due to that forestry. But the fact that you've chopped down the forestry and blocked up the drains means you've got some losses due to the felled forestry, but you've also got gains because your emissions due to that 2 metre depth there have gone down. So your CO2 emissions decrease, your methane emissions go up, but the balance is a good thing.
The 2 metre figure is much too excessive.
That's an
Certainly
example.
Yeah.
That's an example.
What were your experiences of kind of with the water table and the forest?
In the deep furrows, it's down to about 0.6 of a metre beneath the forest surface, and in the highest portions, it's about 40, something like that. So the surface is like this.
Yeah, yeah. But I mean, that was just a number. I might have put that in yesterday. You know, it's just made up. It's just an example.
Is this a situation where this kind of data is probably not actually collected in the site beforehand anyway, in terms of monitoring? And it could be worth collecting if it's actually going to be quite shallow, because then, no, it would be worth collecting if it's deep, because then the benefit is greater in terms of reducing the payback time.
Yeah.
It's the kind of data that could be collected quite easily.
Yeah, and it would be.
You want to get an average water table, you've got to monitor for a minimum of a year to look at differences and get seasonal
In
impact.
thick forestry that might have wind. Yeah, but you can buy diesel loggers quite cheaply as well, a couple of kilometres, and have it logging continuously.
And the fact that you're on the site and you're monitoring for other things, for the ecological aspects of the site, means that you're there and you've got the opportunity to do it, and perhaps you should if you're going to understand what you're doing to your carbon.
I put that question actually under the other, I put that question under the, although Tom was asking about it specifically to the payback under the extension, because I actually thought that with the move towards looking at afforesting landscapes as well, carbon payback calculators aren't just applied to onshore renewables, and therefore there are aspects of what's being developed here that can be used in thinking about what's the best use of this particular landscape. Do we afforest that? What's the depth of the water table at? What difference are we going to make? So it was to think about pulling out different aspects, because it will become as important as it has been with these onshore renewables. I mean, maybe there already are calculators like that, but I'm not aware of them.
There was that Mitchell paper released last week. CAT payback for wind farm and forested peatland in the UK. But it comes up to 2 to 3 years.
What was that, Mitchell?
Is that
Mitchell Grace Harrison from Wires and Peat. I got it from Olivia. Can I just add following on from that, the other thing that we noticed on, I've been working in Penicle, which is another forestry site in South Wales, and the extent of drainage which we noticed on site was nowhere near 50 metres, sort of more, could have been a metre in some places, could have been about 10 to 15 in others.
Yeah, fine. Put that in.
But that would require the heterogeneity component of it, wouldn't it? If you've got a metre and then 10 to 15.
Yeah, we sort of used 15 to sort of show worst case, but I was in your presentation you talked about the difference between vertical and lateral drainage. I was just wondering if you could explain the difference. I wasn't too clear on what you meant.
Vertical drainage means lateral drainage is how much laterally, how much area is impacted. But I have gone to literature and it is like vertical drainage is not that important in peatland. So they used to consider the lateral one.
Can you give a definition of what you mean by vertical drainage?
It's lowering of water table but vertical down.
So when I had a friend standing in a drainage ditch that was this deep, and then a metre away the water was at pretty much at the surface. Is that the vertical element?
That would be
that is that's vertical.
But there's still an impact that you might not see from surface observations laterally.
Sorry.
I'm just trying to understand how you can, if there's a lateral effect and a vertical effect, and you can see the vertical effect because you've got the water on the surface here and the drainage ditch, how can you measure the lateral effect or happens?
So the lateral would be how far away